Okay, this is part 2 of the practice exam number 2 for Math 4A. I'm picking up at question number 14. So, let's try to graph it. So we're going to graph cosecant. Now I hope the main idea is coming across clearly to you, and that is that when you graph sine or cosine, like we did earlier on the test, that's all about looking at the amplitude and especially the phase shift and the period, right? You do the phase shift, and that's where sine and cosine start, and the period, is important because that's the things end, sine and cosine end, their first cycle ends at whatever the start is, the phase shift, plus the period. Anyway, we don't do any of that for the other 4 graphs, for graphing secant or tangent, or cosecant or cotan. We don't do any of that phase shift or period stuff. No phase shift. No period. Well, then what do we do? What do we do? Well, for secant or tangent, in particular, we just set up the boundaries negative pi over 2 to pi over 2, and we put whatever's in the middle between those two and solve. For the 2 co-functions, cosecant, cotangent, we set up between 0 and pi, and we put whatever's in the middle between 0 and pi, and we solve. What's in the middle? We mean this, between 0 and, x plus pi over 4. That's what's in the middle. That's what's plugged in to the cosecant function. So that's what I'm going to put right here. 0, and in the middle is x plus pi over 4 and pi. That's how we don't do anything. Sine and cosine, we do phase shift and period. But for the other 4 functions, secant, tangent, cosecant, cotangent, we don't do any phase shift or period stuff. I hope that was clear to you. So we just do these boundaries between negative pi over 2 and pi over 2. If you're talking about secant or tangent, cosecant, cotangent, we do 0 and pi. Put whatever's in the parentheses in the middle and solve. Okay, so subtract pi over 4 from all 3. So what do we get? 0 minus pi over 4 is just minus pi over 4. These cancel. Got x. Okay, what happens over here? It's pi minus pi over 4. Now what's that? Let me come over here with it for a minute. How do you take pi minus pi over 4? We put that over 1. Got to get a common denominator, which means we need to multiply top and bottom by 4. So I get 4 pi over 4 minus pi over 4, which is 3 pi over 4, isn't it? Because that's 1 pi there. So, all right, so that's 3. So this becomes, over here on the right side, 3 pi over 4. Okay, now what does all that mean? Let me get rid of all this mess now. So what that means is that my graph is going to happen, my vertical, this is where the vertical, remember all 4 of these graphs, secant, tangent, cosecant, cotangent, they all 4 have vertical asymptote lines, dotted vertical lines. The sine and cosine don't. They're totally different. Sine and cosine, that's why we do period and phase shift and all that. But these 4 graphs, secant, tangent, cosecant, cotan, we have the 2 vertical asymptote lines, the vertical dotted lines. And where do they go? Well, that's where we solve these little inequalities to find, this is where the first one is, that's where the second one is. So negative pi over 4. So where's that? We'll come up here to the graph. This is negative pi. So this must be half of that, right? Negative pi over 2. So where's negative pi over 4? Well, it's halfway there. Here, let me do a different color. So in other words, if I can do it, it must be right here. That must be minus pi over 4, right? Because it's a fourth of a pi is half of half. So if this is a whole pi, and this is half a pi, then this must be a fourth of a pi. It's half a half. So that's negative pi over 4. And then 3 pi over 4, where's that? Well, again, this is a whole pi. This is pi over 2, half a pi. So 3/4 of a pi, this is 3/4 pi, is halfway between a half and a whole. So this is 3 pi over 4. All right, so I got my 2 vertical asymptote lines. Now what happens between those 2 vertical lines? Well, for secant and for cosecant, they both have a u going up between those vertical asymptote lines, unless there's a negative in the front. What do we have in the front here? Negative 3. So they're going to have a u going down. Starting where? At negative 3. So I just go down to negative 3. Let me kind of get this out of the way here. Go down to negative 3, 1, 2, 3, and right in the middle. So it's right in the middle between the two verticals. See how that's not, I'm not looking at the, it's between the two dotted lines, right in the middle, and it's going down. See that? Negative, at the height of negative 3, right here, negative 3, let's put it over there. Negative 3 at that height going down between the two vertical asymptote lines. If there was a plus 3 in front, then it would be going up. Normally they're going up. Both secant and cosecant go up. Whereas tangent and cotangent, those are snake graphs, right? Tangent is the one that rises to the right, goes up to the right, and cotant is the one that goes down to the right. But secant and cosecant, those are both U graphs, and all this happens between the two vertical asymptote lines that we always find for these graphs, right? So, all right, so which one has a branch like that barely hits the y-axis right here? Well, look at that. It's exactly that piece right there. That's exactly what we have. See how that is? See how this right edge looks like it's right there between this dot and this dot, just like this dot and this dot here, just like between here and here? It's perfect. And this one hits the y-axis, and it looks like there's a vertical right there. It's A. It's question A for sure. All right, I'm going to move on. Okay, so now we're on number 15, secant. So again, you know the drill. For secant and tangent, we do the negative pi over 2 to positive pi over 2. We put the bounds, we take what's in the middle and stick it in the middle, 2x minus pi over 4. Right? That good? If it was cosecant or cotan, we would put 0 and pi and put whatever in the middle and solve. We do not do what we do for sine and cosine. Sine and cosine are all about period and phase shift and all that. But for these four, secant, tangent, cosecant, cotan, we just set up the triple inequality, the compound inequality, solve for x. That finds our two vertical asymptote lines. And then for secant, we're going to put a U shape in the middle. Once we have those vertical asymptote lines, if you have tangent or cotan, you put a snake in the middle. Tangent, snake going up, cotan, snake going down. All right, so now we need to solve this. This is not simple. So first off, add pi over 4 to both sides. So that's just 2x. Okay, now how do you do that? Well, you got to get common denominator. You got to multiply top and bottom of this guy by 2. So that becomes 2 pi over 4. Plus pi over 4, which is 3 pi over 4, right? Over here, same thing, top and bottom. Whoops, getting a little scribbly there. Top and bottom by 2, that's minus 2 pi over 4, plus 1 pi over 4 is minus 1 pi over 4, or just pi over 4. Everybody see that? Right? Minus 2 pi over 4, and this is plus 1 pi over 4. Minus 2 plus 1 is minus 1 pi over 4. Just minus pi over 4. Don't need that 1. You can have it if you want. All right. Last step, divide through by the 2. Now, the easy way to divide by 2 is just multiply the denominator by 2. Denominator by 2. Gonzo. X is between. Over here, it's 3 pi over 8. Over here, it's minus pi over 8. Or we can keep the 1 if you want. 1 pi over 8. Either way, same thing. So minus 1 pi over 8. All right, so that's where our verticals go. We have to draw vertical lines between negative 1 pi over 8 and positive 3 pi over 8. That's where the two vertical asymptote lines go, the dotted lines, the vertical dotted lines. Okay, so I'm going to go back to the main graph. You can back up this YouTube if you want to see that work again, but I'm going to go forward now and put the verticals on there. So negative pi over 8. Now where's that? That's always a little tricky, isn't it? So here's pi over 2. Negative, I should say, pi over 2. So that's half a pi, you realize. That's half a pi. If I take a pi and I have half a pi, what is this? This is an eighth. So it's like, take fourths, cut it in half again. An eighth is just, it's a really small part. So an eighth of a pi, that's not very much. That's, in other words, that's a vertical really, really close here. Right? Negative pi, it's an eighth of a pi to the left. negative eighth of a pi. Not very much, not even close to half a pi, right? It's only a fourth of a way to half a pi, right? Isn't an eighth 1/4 of a half, right? So it's really close there. And then where's 3 pi over 8? Well, that's just under a half, isn't it? Because 4 pi over 8 would be a half. So here's a half, or 4 pi over 8, pi over 2. So it's close to that, but just under it. So the vertical will be just before that will be 3 pi over 8. That's a lot of the battle, is finding where these things are with the dotted vertical lines. All right, we good there? Right, because 3/8 is just under 4/8, which is a half. So it's just to the left of a half, this being a half a pi. All right, so we've got it. We got the, erase all the other stuff. We've got the 3/8, the negative pi over 8, and the positive 3 pi over 8. What happens in between there? A U shape. Secant and cosecant make a U shape, whereas tan and cotan make a snake in between their verticals. The U shape is always up for both these guys, unless there's a negative in the front, turning it upside down. What's in the front? Nothing. Positive 1. So it's just up. It's just up. Starting at positive 1. Yeah, that's right. Because what is in the front there? Positive 1. Let me try to draw that a little better now. Positive 1. So it starts at 1 and goes up and goes up. But hold on. There's one more wrinkle. What about this plus 2? What does that adding 2 do at the back? Remember what we learned adding 2 does to any graph? Just moves the entire graph up 2. So this dot that was at 1 will go up to 3 and then up. That makes sense? It's at a height of 3. It was at 1 because there's a 1 in the front to U shape starting at 1, whatever number's in the front, but the adding 2 moves it up 2. So it's up to 3. So it's the bottom of 3. So which one of these is at a bottom of 3? Well, it's hard to see it now, but right here, part A, that one is at a height of 3. That one has got the U shape that's in the right spot. And that's the one. Answer A is our answer. All right, let's move on. Okay, let's go on with number 16 now. 16 is giving me A is 1.5. That's this side, 1.5. Capital B, the angle B, is 40.9 degrees. And find C. They want me to find C over here. Okay, so what relationship? Let me see. This would be the opposite and the adjacent and the hypotenuse from the 40.9's perspective. That side's opposite. This side's adjacent. Okay, so we need adjacent over hypotenuse, right? Because I need the C is what they want me to find, and I've got the 1.5. I do not want to use the opposite side at all because I don't know anything about it and I don't want it. I want C. I want C. They're asking me for C, right? Find C, and I have the 1.5. So what's A and O, or A and H, I mean? Remember SOHCAHTOA. SOHCAHTOA. Which one use AH? There it is, cosine. Cosine of 40.9 is AH. So it's 1.5, the A, over the H, which is side C. So there we go. Now, how are we going to solve that? Well, let's find the cosine. Make sure you're in degree mode and take the cosine of 40.9. I'm getting, what, 0.75585, whatever. I don't know how much accuracy you need. 1.5 over C. Okay, solve for C. Now, how do we always solve a fraction? You multiply by the denominator. Even if that denominator is a letter, number, whatever. Multiply both sides by the denominator. 1.5 equals C times 0.75585. Last step to get C alone, divide by the 0.75585. 0.75585. C will equal, my calculator says 1.98. 1.98, which is not here, none of the above. That's the answer. It's good. All right, let's go on to number 17. All right, number 17. They're giving me, this time, same triangle. A is 17.1. So now this is 17.1. C is 26.8. 0.8, and I wrote 1. 6.8. Okay, and find B. So they want me to find angle B. So angle B, this is adjacent. This is hypotenuse. So again, that's cosine, isn't it? Cosine of angle B is adjacent 17.1 over hypotenuse 26.8. So how do I find B? B is cosine inverse 17.1 over 26.8, right? Remember, you put in an answer to inverse trig functions, and what you get out is an angle. It's reverse of a normal trig function. Put in the answer, get out the angle. All right, so I'm just hit the buttons on my calculator. Make sure, again, you're in degree mode. You'll get the wrong answer if you're in radian mode. I'm getting 50.353 degrees, and the answer is rounds to be 50.4. So there it is, C. All right, next problem. Number 18. Okay, a boat leaves the entrance of a harbor, travels 86 miles on a bearing north 58 east. Okay, so we got to get that straight first off. How do you do north 58 east? Well, that means you always first write the straight up for north or the straight down for south. So from here, from this dot, that's straight north, straight up. If they said south, I'd go straight south. You always do that first. And then from that straight up, you go what? 58 degrees to the east. That means to the right. So I'm going to go 58 degrees to the east. So this is my actual direction I'm headed. So it's 58 degrees to the right of north. So you always do north first. Let me go back here. So you do the north first, then you go 58 degrees to the east, to the right of that north. Okay. Now, for making triangles, and then what they're going to ask me is how many miles north, how many miles east does it go? Well, that means straight over, straight up. Right? We always make this is how far east, that's because that's to the right, and this is how far north. Now that means I need this angle right here. You always want the angle on the x-axis. What is it? Well, the whole thing here is 90. So if I take 90, let me do it over here on the side, 90 minus 58, I'll get, what is that? 32 degrees. So therefore, this part must be 32 degrees. Okay, now, and they're also telling me travels 86 miles. So I know that this distance here is 86 for this piece here. Now I can find out the E and the N. So to find out, let's start with the N. That, from the 32's perspective, that's the opposite over the hypotenuse. So that's sine. Sine of 32 is opposite over hypotenuse. So that's what? North over the hypotenuse of 86. How do you solve that equation for north? Multiply both sides by the denominator. It's what we always do with a fraction. N equals, and just hit the buttons on your calculator, 86 times sine 32. Again, make sure you're in degree mode. I'm getting 45.6 north. So 45.6 north is right there. Okay. Now, they also say 72.9 east, so maybe we should check the east. For the east, this is the adjacent side to the 32-degree angle. So the adjacent side, so I would say cosine, right? Cosine 32 is adjacent, which is east, over the hypotenuse, 86. So then, again, multiply both sides by 86. 86 cancels here. East equals 86 times the cosine of 32. And I get 72.9. So it is answer D. All right, let's move on to number 19. Number 19, straight trail with uniform inclination 17 degrees. Leads from a lodge at elevation 800 to a mountain lake 5300. So if you go from an elevation of 800 up to an elevation of, 5,300, how much did you rise by? That trail, which led you from a 800 elevation thing to something way higher up at 5,300. What's your rise? Subtract those, huh? And what is that? 4,500, I think? Yeah, right. 4,500. So our rise is 4,500. So, okay, what does that mean then? That means that we're going on this, we're really doing it diagonally. Right, here's our path. We're going diagonally up the mountain, but that means this rise, over here is the rise. It's 4,500. That's how much we rose by. And how far sideways did we go during, we really went diagonal on the path. But that involves sideways, horizontal movement, and vertical movement. The vertical movement, 4,500. We know that because we went from 800 feet to 5,300 feet. So we rose vertically 4,500. How far did we, and the 17-degree angle on that path, it says. And it says, what is the length of the trail? So they want to know X, this path, this side right here. How long is the path? So I've got this angle, this side, and this. What is that? That's opposite over hypotenuse. That's sine. So sine of 17 degrees is 4,500 over x. How do you solve for x? Or how to find this equation? Multiply by the denominator, both sides x. So we get 4,500 is x sine 17. Last step to get x alone is divide by the sine of 17 degrees. And you make sure you're in degree mode. 15,391. 15,391 is what I got. So that's answer A. All right, let's go on to number 20. Number 20. A building 230 feet tall casts a 30-foot long shadow. Person, blah, blah. You read through the words. Basically, the person's looking up at the building from their eyeballs 6 feet high, and they want to know the angle of the person's eyes. So if you think about it, you get this building 230 feet tall. Here's ground, right? You get this other person 6 feet tall. Here's their eyeball looking up. So really the triangle is going to go from their eyeballs up. So I don't know if I'm being very clear here. It's 230 feet from ground floor to the top of this building. This is ground down here. Ground. This is the ground. And this is the person standing on the ground. I don't know if I'm being very clear about any of this. Here's the person. And there's their eyeballs. They are, this right here is 6 feet high up to their eyeballs. So therefore, what I really want to know, I want this triangle here. How tall is this side? Well, it's 230 subtract 6, 224. So it's 224 from there to there, right? From their eyeball up to the top of the building, 224 feet. Okay, and it's a 30-foot long shadow. Where does shadow sit? On the ground. This is 30, but this is also 30 because this is the same, right? This and this are exactly the same. They're 30 feet. Shadows are on the ground. 30-foot shadow. So, and the question is, what's the angle? So I want to know this angle here. Call it theta or call it whatever you want. You know the 230? No, not 230. Ooh, don't. That's the mistake. You're actually doing the red triangle, right? This red one here. So we know the 224 and the 30. And theta, that's what? Opposite over adjacent, isn't it? So that's tangent of theta is opposite 224 over 30. So theta will then be inverse tangent 224 over 30. Make sure you're in degree mode. Inverse tangent 224 divided by 30. I'm getting 82.37 degrees. Answer C. We good? See why it's 224? Because it's from the eyeballs up to the top, not from the ground. The angle of the person's eyes. So there we go. Hope that helps.